Welcome to Section 7.4, Solving Systems of Linear Equations by Substitution. Hopefully by the end of this, you'll be able to solve systems of linear equations by substitution. So one thing that we did, we solved systems of equations by graphing, but you may have noticed that there's some limitations. What if they don't intersect on a really pretty point? Maybe it intersects at a fractional point. That's a little bit harder to find on a graph. Or what if it's a really big value or really, large value that you don't see on your graph yet? So there's some limitations when it comes to graphing. And so we're going to take an algebraic approach today. So how do you solve by substitution? So just a refresher, the solution to a system of equations is a solution to all equations in the system at the same time. So to solve by substitution, what you're going to do is you're going to take one of your equations and you're going to solve it for one of the variables. So you're going to have maybe x equals an expression or y equals an expression where you've gotten one of the variables by itself. And then what you're going to do is you're going to substitute the other side of that equation, that expression part, into the second equation. So in that second equation, the one that you haven't used yet, wherever there's an x, you can put that expression that equals x because they're equal to each other. Or maybe you put an expression in for y, okay? And then what's going to happen is you're going to have one equation with one variable instead of two equations with two variables. And then that equation that you have that just has one variable in it, you can solve that equation for the variable, and then substitute back into either equation to solve for the other one that you don't have yet. So let's try these, and I think they're going to make more sense as we do some examples, okay? So the first example I have for us, so this is example 1, has 2x plus 7y equals negative 12, and x equals negative 2y. So this first one, I already have it solved for a variable. I have x equals negative 2y. So what I can do with substitution is because the x is equal to negative 2y, over here in the other equation, where there's an x, I can substitute in negative 2y, and they're the same value, which is why I can do that. So what it looks like is just imagine you have a set of scissors and you're going to cut this little part out with your scissors, and imagine grabbing a glue stick and pasting it right here where there's an x. That's what it's going to look like. So I'm still going to have the 2, but where there's an x, I'm going to substitute in negative 2y. I do put parentheses around it just to keep it together as a group. And then the rest of the equation stays the same. I still have a plus, I still have a 7y, I still have an equal sign, and I still have a negative 12. So you'll notice now that I've combined those equations together, I get one equation that has the same variable. Okay, just one variable in it. And I can solve for y. So I'll multiply before adding. So that would be negative 4y plus 7y equals negative 12. I can combine my like terms. Negative 4y plus 7y would be 3y equals negative 12. And then I can divide both sides by 3. And get y equals negative 4. And it feels like you're done, but I promise you're not. So in this system, you need to solve for all of the variables that you have. So we've solved for y, but we also need x. Probably the easiest one is using this second equation, x equals negative 2y. So I'm going to have x equals negative 2 times y, and we just figured out what y was. Y is negative 4, so I'm going to substitute it into this second equation. Negative 2 times negative 4 is positive 8. So now I've got x equals negative 8. And so I can put those together to make my solution. So x is 8, y is negative 4. So negative 4 would be the solution that works for both equations. Okay? Let's do another one. Example 2. The equations I have x plus 3y equals negative 7. And then I also have 4x plus 12y equals negative 28. Okay? So you'll notice that I don't have it solved for one variable yet. Probably looking at it, the easiest one to solve for would be the x in this first equation because it doesn't even have a coefficient next to it. So to get x by itself, all I need to do is subtract 3y from both sides. So I'll have x equals -7 minus 3y, or -3y minus 7. Now that I have an x by itself, I can substitute -7 minus 3y into the other equation where there's an x. You don't want to solve it back into the equation that it came from because that just won't be helpful to you. You want to combine the two equations together. So since this came from that first equation, we're going to substitute it into the second one. Okay, so get your scissors out and your glue stick. Okay, that's what we're going to do, is do the substitution step. So we're still going to have a 4. But where there's an x, imagine you've taken your scissors, you've cut this part out, and pasted it with your glue stick. And that'll be -7 minus 3y, where there is an x. The rest of it stays the same. I still have a plus, I still have a 12y, I still have an equal sign, and I still have a -28. Now I have one equation with one variable, which is easier to solve. So from here, I will distribute my 4. So 4 times -7 would be -28. 4 times -3y would be -12y. We still have a plus 12y, and we still have a -28. From here, if I combine like terms, that -12y plus 12y, that's 0. And what happens is we cancel out our y's. So we don't have them anymore. That equaled 0, so now I have -28 equals -28. So this is what the special cases look like when you get to substitution, is it's either no solution or infinitely many, because we got rid of our y's. Since it's a true statement, that would be infinitely many. These are actually the same line. They would be graphed on top of each other if we were going back to that graphing method. If we had a false statement, maybe -28 equals 0 or something like that where it was not true, that would be no solution. But this is what it looks like when you have a special case. And so we would have infinitely many solutions. Okay. All right, let's try one more. In example 3, it has fractions in it, which I know can be a little bit intimidating. And so honestly, the first thing I'm probably going to do is to clear my fractions out so that it looks a little bit nicer. I start out with 1/2 x plus 1/3 y equals -1/3. And then the other equation is 1/2 x plus 2y equals -2. I didn't really need to separate this by a line, did I? So the first thing I'm going to do is just get rid of my fractions, okay? Because it'll just make it a little bit cleaner. With 2 and 3 as my denominators, my LCD would be 6. So I'm going to multiply both sides of my equation by 6, just to make it a little nicer looking. So 6 times 1/2 would be 6/2, which would simplify to 3x, plus 6 times 1/3, that would be 6/3, which would be 2y. And -1/3 times 6, that would be -6/3, so that would be -2. That looks a little bit better. With my second equation, I'm just going to multiply everything by 2, since the only denominator I have is a 2. So 2 times 1/2 x, that would be 2/2, which would simplify to just 1x. 2 times 2y would be 4y, and 2 times -2 would be -4. So that looks a little bit better than how we started out. From here, I still need to get in a variable by itself, so how about we get the x by itself, since it doesn't have a leading coefficient anymore. So I'll subtract 4y from both sides, so I'll have x equals -4 minus 4y. Then I can substitute this into the first equation, where there's the x, okay? Because it's x equals, we're going to put it where the x was. We're going to use the other equation than we started out with so that we can bind them together. So what this is going to look like then is 3 times, but instead of x, we're going to substitute this little expression in. That'll be -4 minus 4y. And then the rest of it stays the same. I'll still have a plus, I'm still going to have a 2y, I'm going to still have an equal sign and a -2. So the rest of the equation stayed the same. Then I have one equation with one variable, which I can solve. From here, I'll distribute my 3. So 3 times -4 is -12. 3 times -4y would be -12y. and the rest of the equations stay the same. I can combine like terms. Negative 12y plus 2y would be negative 10y. I still have a negative 12 on this side, and it still equals negative 2. To solve from here, I'll add 12 to both sides. So now I have negative 10y equals positive 10. And then I'll divide both sides by negative 10, which means that y equals negative 1, which is nice. And as much work as we just did, we're not quite done yet. We've solved for y, but we don't have x. So to solve for x, there's a lot of choices. You could use one of the original equations if you would like to. You could use one of these equations after we multiplied by the LCD. I'm going to choose this one because it's already solved for x, and that just seems exactly what I'm looking for. So I'm going to have x equals negative 4 minus 4 times my y value, which we just solved for, and it is negative 1. So I'll multiply before I subtract. So I'll have negative 4. Negative 4 times negative 1 is a positive 4. So now I've got negative 4 plus 4, which would be 0. And 0 is a number. It is not no solution. It is a number. So our solution is x is 0 and y is negative 1. And that is the answer that works for both equations at the same time in this one. Now it's your all's turn. You get to try one and show me how much you've learned.